Hi everyone, I'm Wil McReynolds, CTO of KP9 Interactive. We have a WebAR platform called WorldCast, and today I'm going to talk about natural feature tracking and natural feature recognition for our system in many ways, but also the same practice and knowledge can be applied to other systems that use natural feature tracking and recognition. And I'm going to explain those right now. So let's get into it. So right now I'm sharing my phone. I'm going to show you a couple different surfaces, a couple different angles, and talk about some things, and then show you how to make them the best designs as well. Okay. So one of our best practices is our system will for natural feature tracking. If you scan a QR code, it will bring up the image, and the idea is to get them to bring it in as close as possible to the actual scenario. Right. I mean, this is a super glossy can. You can see all the reflections of my hand on that. So as soon as I mess up that tracking, but we've made it so that it works pretty well, right? Now I can go back to a certain extent, but that's when it's going to lose a lot of tracking, because now it's looking at a lot of the environment as well, plus trying to track this very shiny can in reality. Okay, so that's one example of talking about how to use environment. I'm going to show all this. Talking about natural feature recognition. What is that? That's if you have an image, and let's just do this. Let's just go scan image. I'm going to look at this print, and it's going to go, hey, I know what this is, by talking to our server, and then bring up the content for that print. Now you notice how it's a little wavery if how I'm sitting there, even if I go on a slant, on a horizontal. We're going to talk about this as well. This is a really good tracker. It's locking right to the print, like it's on there pretty stable, right? Except for that fluttery, and we're going to address that. Like it's on there really solid, except it is a little bit fluttery when you come in and are looking at it and want to do that. Okay, we'll go back to this one. Another example would be to scan a QR code. So let's just use the same one. We'll use the built-in QR code reader in our portal instead of going to the native one, but we'll just scan this QR code. And this is the example of making, you could use the QR code to activate it as well, right? And just line up the images we talked about on the can already. Now let's show you a super solid scenario, but something that has great tracking, but does not have the best, recog. So you saw how fast that one recognized. Let's just scan this image, and this is going to take a few extra seconds because it doesn't have the best. It doesn't have the best recog because it's got a lot of blurred edges and a symmetrical unit in the middle. So let's just try to get this to recog. You can see it's taking a while. This is a great illustration of it taking forever versus that first one you saw, which just literally took like that. So this is where people get pissed off when they're trying to do something, and this is why natural feature recognition is not there yet. It is there. We built an extensive system to do this, but people are just getting used to QR codes. Let's not run before we walk a little bit with people getting used to augmented reality in many ways. So this is that tracking experience that you saw in my videos. You can see how super solid this is. Right, and it doesn't have any of that wavering problem. Okay, I mean, I can go pretty darn near horizontal on the table, and it's still tracking. So let's get into this. Let's talk about why. So you have a tool. You can go to studio.worldcast.io/TIA, and this will give you a tracking image analyzer. And this is so you don't have to go into our system to get to that point. You can just drop an image in there, right? So let's look at these images. So I'm just going to simply drag and drop the one that you just saw, first and foremost. And you'll see the system's got all these key points, what we call them key points, around for the tracking. You can see there's a lot over here on the left, there's a lot on the right, there's a lot in the center. So that means as I move my phone around, I can go away from center and have it nice and stable, and even on certain angles. Because as a phone goes onto an angle, all the data in the camera is being translated back to the server. Now it's being distorted, it's being skewed, it's now not the same as, it's on an angle now. I'm just trying to generalize this the best way without going too deep into it, and this is what I wanted to do. This is kind of like bring it down to the, let's not get too technical about it. Let's just talk about kind of what it's doing. So when I look at it, it's able to stabilize on that surface because all the key points are distributed nice and even, and the camera can see it at multiple angles. If I go back to this one, and let me just analyze this image. So we can see these ones are spread out. If I take this image, make sure I'm still sharing. Yep. And we're just going to bring it on top. You'll see how they're distributed down the center and not so much over in these areas. And there's a lot here and some up here. So if they're not distributed evenly across the plane, think about a log going down the middle, and the computer vision's looking at it. And as I move the phone around, go down even further, it has nothing on the edges to stabilize, so it's stabilizing on that center column, as it were. And every a certain amount of time, every frame, our system analyzes and keeps tracking and poses to make sure it's there. There's nothing to grab onto the sides. It's doing its best to keep on there, and maybe fighting the information in certain other ways. But this is an example of not having information on the sides, and that's why when you look at this, let's just use the scan image to show you how fast this is versus the one that you just looked at. This would be like that. And we can see how, as I'm talking here, these key points up here are now further away. These ones down here, you can't see my finger, these ones down in this area at the bottom are being distorted. So as we go down further, it's trying to keep the pose estimation going, as nothing is up in these corners to grab onto, right? These ones are being radically distorted down at the bottom, so you won't even lock on to that area, and it's losing tracking of the top. But if it had more data distributed evenly across, it would work, okay? Actually, while I'm on this poster, let me show you how fast this is to actually add something to in our studio. And we just released drag and drop. By the way, I work a lot with music for deep focus, so I'm using a ebeatsmusic.com. They're royalty. They let me stream the music without having to pay for it, and I just have it on certain music, so I can just do this. All right, so we have this loaded. This is the this is the flyer that you just saw. Let's just quickly go Sketchfab. I know I'm getting away from that kind of showing system, but it all works out. So let's just go zombie. We have Sketchfab directly integrated into the system. I think I saw one earlier this week that I kind of dug. Taking longer to find the. Curse you, Sketchfab. There's too many of them all. Let's just grab one. Fine. Let's just grab this one. So we're just going to import it directly into the system. I'm just going to make this full screen so it makes more sense. So the model came in. I'm just going to scale it up. We have all the translate controls over here. This is studio.worldcast.io. We have 3 studios: PrintCAST for marker-based, GeoCAST for markerless, and GeoCAST for placing content and reality at any location. So I'm just going to go like this. Now we could actually add a URL click to it if we want to, so you could then make this an interactive object to touch, or go to URL, open a phone number. We have it glowing. We could add some bloom to it. But in this case, let's just go save. And you'll see how fast this actually was to add that content. That content will be there as soon as I scan this image again, or scan the QR code, either way. So to keep it within the realm of building this for anyone, let's bring this up to design any tracker marker for any system. Let's just go back to our analyzer. Let's start talking about this. So if I was to use a circle with just circles in it, that does not make a good tracker at all. This does not make a good natural feature tracking at all. It's too symmetrical. The system doesn't know which way is up in so many ways. Now, if I was to take that same one and add some lines to it, actually I just have to refresh this. You'll see that we now get some extra tracking, but it wouldn't make for a good recall. I wouldn't be able to do that natural feature recognition by just scanning the image, just like it was a QR code instead of using a QR code to activate the experience. So this would not be a very good, and it still wouldn't be that good for tracking in some ways, because it again it wouldn't know which way it was actually up when it looked at it. So when you put your scenario on it, it would just be challenging in a lot of ways. It'd be fluttery as well. So let's take it a step further, and let's add some characters to this, so we can get a little bit more points on and have it know which way is up. Now here's where it gets a little interesting. If you're designing something and it's going to be used in an environment, like maybe it's at a museum, maybe it's a podium with a graphic on top of it, with similar colors around it. Maybe it's for a trade show. So the camera is picking up extra environments as well, so that can make it more challenging for recognition and tracking, as it's trying to take the images that it's taking on the camera, sending to the server, right? It's sending that, once it's on the system, it's fine. For initial recognition, it's going to the server, but after tracking, it's all on device. But the device is still processing all those frames and all that extra information. So if you had something cut off with at edges, as an example, I wouldn't use this. Let's refresh this. I wouldn't use this in an environment if I had a background with a bunch of happy faces and other things, or similar colors and stuff, because it could get messed up. If it was mission critical, like we do with some of our marketing pieces, we put a frame around it to allow it to understand the boundaries. And let me illustrate that with a graphic here. So let me take the one that we just had. So I wouldn't use this kind of background that just falls off, and something might have a lot of white and black spaces or similar things, or high contrast area. I would choose to take I would put a border on it, and you'll notice how all of a sudden we get these key points around the border once I've analyzed. There we go. So you see how these key points are around the border as well, but nothing falls off. So the system, when it's tracking, would use that border to help contain it. And you might have seen other systems have borders and stuff. Our system doesn't need them. I'm just saying, if you're designing something and you really want to make sure it's mission critical in an environment, you may want to utilize that in elements like museums and stuff, and help that tracking be even more robust and a little bit less better frame rates on the devices. It's not trying to process extra information around those images. Contrast, asymmetrical designs, lines. Actually, let's get into that. Color shifts, like having hard lines. This example I'm about to bring up would not be a very good example. This would be a crappy marker, but I want to illustrate something here. Hard cutoffs on colors and stuff, like also firm lines. What you want to do is have like line art, like cartoons, graphics, clip art, elements like that work really super well for natural feature tracking. But in this case, I wanted to give a cool little optical illusion. What colors do you think, when I change this to grayscale, since the system does look at it in grayscale, would look similar? Any guesses? Well, check this out. I'm going to go adjustments. I'm going to go mode, grayscale. And you'll see that these colors over here have a similar tone when they get converted to grayscale. There's no definitive edges. So if you have elements and stuff like graphics, keep in mind that you may have, like, maybe you put a bunch of stars that are orange on top of a blue background, and you think that's going to make enough difference for the tracking. If you had these two similar tones that happen to be the same in grayscale, they would not show up and behave as expected. So nothing would be in that area. That's why I made this graphic. This graphic in itself would be a really horrible recall again tracking experience, just as is. but I want to illustrate colors. It's like if you take similar colors that look the same in grayscale, they're not going to be different from the background that it's on, and they will not get analyzed to be part of that overall tracking structure or recognition structure. Again, I stand by QR codes to be able to use instead of using natural feature recognition for now. Our system supports 4.2 billion unique images per database, and you can scan all day long with it without using QR codes. Again, the general public's just getting used to QR codes in so many ways. It's been, I've been in this for 10 years, and COVID's actually really helped the QR code become a lot more prevalent in North America, especially Canada over the years. But I do want to jump over to QR codes for a second. So you can actually make QR codes become a marker as well. So I'm just going to use my native QR code reader just to show you. So I'm going to open this up. So of course it's going to say line up with the QR code. I'm going to do that. Sorry for the delay. The internet is a little slow here tonight for some reason. I'll just forward off the network here in a second. Yeah, let's just change over to the turn that off. All right. Yeah, that's because I stopped it. Thank you for telling me that. So I just changed off my Wi-Fi. The router for my office for on my phone is across the a little bit further away, and I haven't put a repeater in yet since we moved here. Okay, so this should work a lot faster because I'm just on the network now. Now, the QR code itself does not make for a super amazing tracking experience. It works, but this would be great for putting quick information at spots to information on how to do a thermostat, or how to is right at the location of the where the QR code is. It's not going to bring any rewards for being the most stable, but it does work, and it's areas if you just want to put a QR code. So QR codes do work really well in the system. I just wouldn't rely on a mission critical tracking if you want that Uber tracking experience, right? So I think that covers the majority of things. Let's go back to one studio here. So this is the scenario, and I'm just going to replace this image and show you how bad it can be with a bad image. So I'm going to go to cast properties, and you can see even up here it says the recog is horrible, as it was on the other score. So the trackability and the uniqueness is perfect. In this case, I'm going to go select a new file. I'm going to select file. Let's go to 1 second, please. Let's grab this one that has absolutely no markers or no tracking information around it. All right, so we're just going to go to update, and of course it's got great trackability and uniqueness because it's going to grab all the center points on here, and we'll illustrate that over on the tracker before we actually do this. See? All right, so let's go back to the studio. Should have done that first. It's a good thing the system's fast. There's absolutely no code in this. So, I mean, I don't even know how many minutes I'm into this, and where are we at? Well, we're at almost 20 minutes. I didn't think that was a lot of stuff. Okay, let's go update. And let's go save. Let's grab some other music here. Alright, let's return to the studio. Let's scan, actually, you know what, let's just save that one more time. So I'll just scan the QR code because it's be a lot faster than trying to scan images we've seen with natural feature recognition. So I'm just going to scan that QR code. And we'll aim at this image. My phone keeps on going blacked out from the screen sharing. So this is even the problems are because it has nothing other key points to try and grab. So this one's a little bit more tricky to try and get on there. And for some reason, actually I know what this is. It's because I just saved it. So it takes on our system. It takes about when you upload the new image, when it's going to the server, it could take up to 60 seconds, up to a minute, depending on how many other people are on the system at once. On our processing server. So let's give it a few seconds here. Wow, that music's really chill. So let's just refresh this. There it goes. That's all it was. It just took a second. So this is why we do this. I do this all in one take to show all the flaws and everything, but to talk about the why. And again, this isn't all just about our system. This shows you this would be like any system. So if I come across, you see how it's a lot more jumpy. If I go away from center point, it gets really, it's really trying. It's like I'm trying to stay there, and if I go over here, it's gone. Right? See, I can't go away. I can't go that far over, and I get this much of the image in there, and then it's gone. And let's go back to the other image and illustrate that. And that will pretty much illustrate the best it can get. So let's just go to change this back. Update. Save. We'll give it a few seconds. Return to studio. While it's doing that, let me illustrate the drag and drop while we know it's processing. Again, I try to make this very clear. This is not just all about our system. This is all about how to make good tracking images. So we talked about how if you have something down center, not distributed, things can be a little jumpy. And we just illustrated that again by having just the graphic with the rest of it outside of that graphic as to go away from it. It's trying to keep it stable across a surface that has nothing to grab onto. So let's just bring this folder up beside this. Let's make this on this side, and I'm just going to drag. I'll just drag this video in here. It's going to come up and say, "Hey, this is the video." So I'll go proceed. If it's a green screen, we can filter the green screen. There's lots of other tutorials we have, but I'm just going to make this bigger. And maybe I'll just bring it up to the front and up. It's hard to do on, this is on full screen. It's meant to be full screen. All right. So here we go. Now we have that video. Maybe I want it up higher. Let's make it smaller so we can see all the other content behind it. And we'll also go save, because this does not affect the, this does not impact the actual tracking marker now. Once the tracking marker is in play, these changes are live as soon as you scan it, unlike the processing for the actual image itself. So you can iterate, you can constantly keep on changing it and look at it every few seconds, and it will be the content will be there. So this video will be there now. That is put on a few seconds ago. Now we do have a lot of content coming in. We have a bunch of 3D models. We'll go look at how big this cast actually is here in a minute. So there's that video of me playing. You can see that all that is nice and stable because of that distributed key points across the surface of that item. So we can get really good, robust tracking from even a pretty good distance away from that image. If you've noticed during this tutorial, every once in a while I pause. my screen actually turns black on my phone while it's still broadcasting. There's a little bit of a delay, so it's just a little bit of a pain sometimes. So to me, that tracking is really robust, and that's because of those distributed key points across the entire surface of that element. If you can follow those directions on how to make sure your tracking can be as distributed as possible for those key points, please use our tool. Go to studio.worldcast.io/TIA and you have access to this tool. And go to studio.worldcast.io and make some free stuff. There's a freemium version where up to 500 views a month and only a few limitations, like you can't do green screen video, but you can upload your own custom model. You can use Sketchfab, you can use Canva, it's all integrated. Or of course, use other systems based on some of the tips and tricks I just showed you. And hopefully it wasn't too long for everybody. Thanks so much. I can't wait to see what you create.